Hi, my name is Morgan Casimus. This is my final project on superhero characteristics for my practicum at Regis University. Today I'm going to be talking with you about the data that I used, the questions that I was trying to answer, exploratory data analysis that I did in Tableau, data cleaning in R, exploratory data analysis in R, and then finally my classification model where I chose to use a Navy and Bayes method, and my final conclusions. So the data files that I found were two matching files with over 660 superheroes in them, and they came in two different sets. The first set was all about the demographics, so things like gender, race, publisher, alignment, height, hair color, eye color, weight, these sorts of things, about 10 demographics in all. The second data file had over 160 superpowers, and each superpower was a logical true-false for whether the superhero had that power or not. So a really interesting data set that I thought would be really fun and make for a nice, exciting final project. The questions that I chose to answer are: what are the most common superpowers out of all of the over 160 superpowers out there? And using those superpowers, would I be able to predict a superhero's alignment? So were they good or bad based on those powers? The first thing that I did is upload my data to Tableau to do some exploratory data analysis and look for the most common superpowers. I chose Tableau for this exploratory data analysis because I really wanted to be able to pivot the data and see all of my characteristics or my superpowers in one column so that I could identify clearly of all of the trues what are the most common. So you can see here super strength is the most common characteristic, followed by stamina, durability, super speed, agility. And again, this list is over 160 powers long, superpowers long, so it's a really exhaustive list. It wasn't surprising when I found that super strength and stamina were the most common characteristics or superpowers for superheroes. If you think about it, pretty much every superhero that I've ever known is super strong and has the ability to fight for hours, which is why we get to enjoy 2.5 to 3 hour long movies. Next thing I did is look at that alignment breakdown. How many or what is the proportion of good and bad superheroes out of the set? You can see here that 70% of the superheroes are good and only about 30% are bad. I did do some data cleanup when I got to this stage. When I looked at the alignment, I not only had good, bad, but I also had some unknown, some neutral, and some nulls, or just some blank rows in my data. I decided to go ahead and remove those out of the data for my analysis moving forward, because when I got to my classification, or when I get to my classification, I really wanted to be able to have a clean cut, were the superheroes good or bad. I also wanted, because those that fall, this number of superheroes that fell into the neutral, the nulls, or the unknown was so small, I just didn't deem it necessary to keep them included. After looking at alignment on its own, I wanted to see how alignment compared with super strength and stamina, to see the proportion of superheroes that had super strength and stamina, if that was similar to the overall. Super strength, I was surprised that just over 60% of the superheroes that possessed super strength were a good alignment, so a little less than the overall proportion. Stamina is 70%, those that possess stamina are good, so I thought that was really interesting. Then I moved on to look at the demographics themselves in a little more detail. I started with race. I was really surprised to find that while there are many of the superheroes had an unknown race, there is an incredible amount of detail to the superheroes that did have race. So not only do we have human, mutant, vampire, cyborg, all of these things, but we have all of these other different types of races that I thought was really interesting. I also looked at gender. Not surprisingly, most of the superheroes out there are male. We know this. Very small proportion have that unknown gender. Then I looked at hair color. Again, a lot of these superheroes have an unknown hair color, but at the largest amount do have black hair. And eye color, largest amount have blue, but again, we have quite a few that have an unknown here. And as I was going through exploratory data analysis and seeing a lot of these unknowns, that influenced what I chose to keep in or not keep in my classification, or excuse me, my classification later on. Then I looked at height and weight, averages and medians. My averages are the bars, medians are the circles. You can see my median height and average height are really much pretty spot on with each other, where my median weight and average height are a little bit different. My median weight's a little bit lower than my average, which just tells me I have a little bit bigger range or wider range in my height, in my weight than I do in the height. And the last thing I looked at the demographics was the publisher. I was really only aware of Marvel and DC as publishers, so it was really interesting to see that there are many more publishers out there making superheroes. So once I finished with my exploratory data analysis in Tableau, I moved on to my data cleaning. As I mentioned, in Tableau, I did some cleanup already. There were some spelling errors in some of the hair color and eye color, and I went ahead and grouped those together. And then my alignment, where I removed those unknowns, nulls, and neutral groups. So then I uploaded my data to R. I joined them using the diplar package. You can see my code here, and then a small proportion of my output. Again, a lot of variables, so you'll see a lot of snippets of things as we move forward in R. I then did a little more exploratory data analysis in R. I wanted to dive into those heights and weights a little bit more and see, what was really pulling things down. So here's a box plot of my height. Pretty typical standard, it's what I expected. There's a box plot of my weight. First thing that I noticed here is I have all these potential outliers that are, below 20, which means I have potentially a handful or so of superheroes that have really, really small weight, which I think is really interesting and potentially more analysis for a different project. And the last thing I did from our exploratory data analysis was look at the alignment, so good or bad, in relation to the publisher. One of the things that I wanted to do here is really know how many superheroes each publisher had, and then if some publishers were more likely to have good heroes or bad heroes. I'm really more thinking in that bad hero, since I know 70% of the superheroes are good. First thing that I noticed, as I saw in my graph earlier, that most of the publishers outside of Marvel, DC really don't have that many superheroes. The second thing that I noticed right away is George Lucas has 12 superheroes, and 6 are good and 6 are bad. So that's definitely an area where maybe a little more balanced, if you will, of the superhero alignment. So once I had finished my exploratory data analysis, I was ready to move on to my actual classification. So I used a Navy and Bayes classifier, and I did this because I had over 160 superpowers, and I wanted to use a model that was going to allow for some noise and without potentially reducing my accuracy rate. So that's why I chose Navy and Bayes. The other thing that I did here is, after seeing so many unknowns in the different demographics, I opted not to include any of the demographics except for publisher in my classification, because I just felt like there were too many unknowns that would potentially throw my model off, or be a little bit too much noise, since I really wanted to focus on the superpowers themselves. So here's my model. You can see my code. You can see a small portion of my output, and then here's a portion of my output that looks directly at the superpowers themselves. So you have the agility, how many are true, how many false, and then the proportions of good and bad. So I was finally ready to move on to my prediction. You may have noticed that I didn't do a test and train data in my classification. I ran a few different models on test and train data, and it really didn't, if I used test data or train and test data versus not, I still really had the same accuracy rate. It didn't change much. So for my final presentation, I decided to just present without it. But for my prediction, I had a 78% accuracy rate. This isn't the best accuracy rate I've seen, but I'm pretty happy with it. I'm not predicting if a cell has cancer or not, so having a 78% accuracy rate to decide if a superhero is good or bad based on their superpowers, I feel pretty comfortable with. Yeah. So finally, in conclusion, I was able to identify the most common superpowers for a superhero, which are super strength and stamina. Again, not surprising here. And then I was able to predict the alignment of a superhero with a 78% accuracy rate, which I think, again, is pretty solid for what I was able to do. So thank you very much for watching my presentation, and I look forward to your questions on World Class.